Could not help myself, just had to make one more space video as I was headed home from the gym. I was at ATC Fitness. I saw this beautiful grouping. Again, it's the Moon, Jupiter, and Saturn. But what caught my attention was the way the angle of the Saturn-Jupiter line has changed relative to the horizon as the two planets move further westward, and that is due to the curvature of the Earth. When we see the pair earlier in the evening, they are more flat or horizontal, shall we say. If I zoom in on Saturn, you'll see that it's a little lower than when I filmed. How should I say this? It's when I filmed Jupiter and Saturn last night. It was a little earlier in the night, and the two were more or less horizontal, or more horizontal than they are now. As it gets later, due to the curvature of the Earth, we turn at such an angle as to make the two appear less horizontal, and Saturn appears lower in the sky than Jupiter as they descend more toward the west. I'm trying to explain this without aid of a chalkboard or easel or anything like that, but suffice to say, earlier, it's about 12:15 a.m. now on the morning of September 19th. But as we go earlier in the night and into the evening, when the planets are up, they will appear more horizontal, with Saturn relatively higher compared to Jupiter, and the two are more or less at an equal height above the southern horizon. I'm looking toward the south right now, almost directly south, as the two planets move toward the west. But be that as it may, today was a rainy day in Memphis, but the sun came out toward the very end of the day. Actually, it was partly cloudy at the very end of the day, and the sun came out as it was setting, which is really pretty. Again, these two beautiful gas giant planets, each of them have 80 known moons. It's almost certain that there are others that have not been discovered. Jupiter is 318 times the mass of the Earth. So if Earth weighed 1 pound, Jupiter would weigh 318 pounds. And Saturn is 95 times the mass of the Earth. So again, 1 pound Earth equals a 95 pound Saturn. So that gives you an idea of the mass of these gas giant planets, made up of mostly hydrogen and helium with other gases. But of course, those gases are compressed. They're not in air form like we have here. We think of gas, we think of the air that we're breathing. The gases on these planets are compressed first into an ever-increasing dense gas, and then into a liquid. Then from there down to metallic hydrogen, liquid metallic hydrogen. So you can say they're made of gas, but it's really metallic. Most of the mass of the planets is metallic and liquid hydrogen and helium, with perhaps a small iron core. We don't know for sure. That's mostly speculation.